Hey guys, how y'all doing, and welcome back to the channel. My name's David and I fix RVs, and today I'm working under my bed again. Let me show you what I'm doing. Today's project is this transfer switch slash inverter. I'm going to be using this inverter slash transfer switch to power this one outlet that's right at the foot of my bed. And this one outlet is used to power my computer, my Wi-Fi router, television, an oil-filled heater. And this is the rest of the setup. I got the 314 amp hour LiFePO4 battery, got some positive and negative bus bars in there, and a converter charger. For this 55 amp converter charger, I've got a 60 amp blade fuse right here that just goes from the charger straight to the bus. And then I've also got an 80 amp air conditioner, so I installed an 80 amp blade fuse for that too. This bus bar, I pretty much just installed that so that I could run my air conditioner wire in. And then I've got my blade fuse coming out up to the bus bar right up here. And then from the bus bar, I jumped down to a mega fuse right in there. And this guy is coming from this inverter. Now, the only thing I have left to do is I've got to get power into the inverter from the mains, and then I've got to get power out of the inverter to this outlet right down here. Now, I do have power coming from the main to this outlet already. Then it jumps out of this outlet over to this outlet, which is what I plug my converter charger into, and both of those wires are daisy chained together, and then the wires are pigtailed on right onto this outlet here. So I've got one wire going in from the main, one going out to the outlet in here, and then a pigtail that comes out to this. Now, if the power goes out, the automatic transfer switch will keep this power working. There shouldn't be any delay either. We won't have to reset clocks. It won't affect computers or anything. This outlet in here that the converter charger is plugged into will die, which is what we want. We don't want the converter charger to be plugged in and charging the battery during a power outage. The air conditioner wires are only long enough to come to right about here underneath my television, so this is the junction point that I added. And then I installed a shunt which monitors the air conditioner. It also keeps track of the voltage at the battery. And then from there I extended those wires down. I had to add about 4 feet to get up under the bed into this area. I do have some space right there to add another battery in the future, or even more back there if I want, but I bought a second battery and a third battery actually, but the other two that I bought were the smart batteries. They have Bluetooth. This one does not have Bluetooth. I talked to WattCycle about paralleling the smart batteries and the dumb batteries together, and they said that they don't recommend it. So for now, this battery is going to be on its own. In the future, though, I will be paralleling a second battery in here. I also want to have a second battery just in case I decide to upgrade to a 24-volt system later. This right here is a 12-volt system. And after I wrap up in the bedroom, I do have this 24-volt all-in-one system. This is going to power the rest of the RV. I'm just kind of isolating this one outlet from the main panel. Like I said, this is a 24-volt setup, so I've got this is a 24 to 12-volt DC to DC converter. This is going to be the only Victron product that I have in my RV. I most likely will be picking up a couple of Victron shunts in the future, probably one for the bedroom and one for the main panel. The outlet that we're working on the bedroom is a dedicated outlet coming from the RV pedestal, and we're plugged into this 20 amp GFCI outlet. This outlet is isolated and completely separate from the rest of the outlets and the rest of the electrical system in the RV. I've got a ground bar down here with a solid number 10 copper wire coming from underneath the RV. I actually bolted that right to the frame of the RV. Then I've got 2 jumpers coming out of it. One of them comes from there to the converter, and then the other one is coming over here to the inverter. So that pretty much sums up what I've done already, and what I have left to do is this. Let's get started. I've set up some metal flexible conduit down here just to give the wire a little bit of protection, and I've got my line and my load are already labeled. on both ends, line and load here. If you don't know, line is going to be the power going into the inverter, load's going to be the power leaving the inverter, going directly to that outlet right down there. Now I've got this outlet apart. These wires are the power that are coming in from the RV pedestal, and these two are the wires that are going out to this outlet in here that goes to the converter. So the next step is to run those new wires in here. The line wires are going to get tied in with these two. Then I'm just going to wire nut them all together and roll them up in the back. The neutrals, you know, are going to go with them. And then the load wire, we're just going to hook that directly to this outlet, so the wire coming from the inverter will not be tied into any of the other wires. It's going to go only to this outlet. Here's a little something I like to do with my line. I just twist it a couple of times. That way I don't forget which is which. Now that we've got everything separated, you can see that this is the load wire coming from the inverter. That's going to be the power for the outlet. That's the only wire that's going to go here. And all the rest of these wires, the whites are all going to get junctioned together. The blacks are going to get junctioned together. Then I'm just going to roll them in the back. Now this side's done. Now we just need to move on to the inverter. This guy comes with Wagos. That's the neutral, ground, and the line in. And that's the neutral, ground, and the line out, load. Alright, let's strip these wires and get them in. I was going to use this wire as a gauge to let me know how far that goes in. Okay, we've got them all cut off to the correct length. That's my line. Line goes right here. Let's close that one. Ground goes in the middle. I didn't really like the way that looked with the insulation outside of the case, so I redid it. And I also got my shrink wrap on there. All right, hit the breaker. The power is on the inverter. Let's look down here. The charger, converter charger is charging. Down here, the outlet is working. Now I'm going to go outside and turn off the breaker so we can simulate a power outage. Let's see what happens. You guys probably know better than me. I got to roll the video back, but hopefully that outlet didn't go off at all. Well, I just rolled the footage back. I'm sure you guys saw that it just blinked off for just a second and then back on again. I'll have to do some more testing with the computer plugged in to see what actually happens with the computer. Hopefully it doesn't shut down and have to reboot. All right, I've got the computer turned on. Now let me go hit the breaker and we'll see what happens. Hopefully nothing happens. Well, that's great news. This system is working exactly as I hoped. Right there it shows that we are running on battery and the converter charger light is not blinking. This is exactly what I wanted. My next video should be the all-in-one system install for the main panel. Alright guys, I hope you enjoyed my little update video. Thanks for watching and I'll see you next time.